Hello and welcome to the second instalment in the Cleanroom Technology Roundtable webinar series. Today we are excited to be joined by Bo and Zuri from Nortec and Mark Wheeler from the Guardtech Group. We hope that you will find their presentations informative and enjoyable. Once the presentations are done, we will be moving on to the Q&A section, so please make sure that you stick around for that. And without further ado, I'd like to hand over to the Nortec team.
Hello, everyone, and thank you for joining. And thank you, Cleanroom Technology team, for hosting this webinar series and the design build installment. Today, Zuri and I address the challenges faced by contractors, architects, and engineers in the world of cleanroom design. We will go over insights on navigating the intricacies of cleanroom sealing systems, and we'll give you perspectives on architectural requirements, technology integration, and future trends that are shaping cleanroom spaces and their construction. All of this is really critical aspects that help to achieve a coordinated project while addressing project cost and keeping a project on schedule. In this introduction video you see playing with a semiconductor fab example, you're seeing not only the ceiling itself, but the critical components it must integrate with and really work as one system. Designing a cleanroom sealing system is a critical aspect of creating that controlled environment and meeting specific cleanliness and safety standards. The sealing system plays a significant role in maintaining cleanliness, controlling airflow, and really ensuring the overall functionality of the cleanroom. It also needs to do all of this within construction requirements that should help optimize overall cost and allow ease and speed of installation. So with that, let's get into all those crucial design elements now. Zuri?
Thank you, Bo. A trusted partner will be able to guide you through a selection of key criteria when designing the proper sealing system for your cleanroom. It's useful to start with an initial checklist of key specifications to build from. What is the required ISO class level or CGMP grade for the cleanroom? This will drive criteria such as air changes per hour, filtration type, and the amount of coverage, amongst other things. The architectural design is linked to desired functionality, access to serviceable components, and if access needs to be from inside the control environment or top side of the ceiling in a serviceable interstitial space. On the structural side, it's important to understand what type of loading is on the ceiling system and how it translates up to structure, and if the building can take these loads or if it needs to be configured as a floor-supported system. Lighting targets need to be specified, and additionally, sound level and vibration targets should also be specified.
Thanks, Zuri. And what are some of the airflow considerations?
Well, it's important to consider how much space is available above the ceiling. This might drive how the air is served to the ceiling, either with recirculation air handling units, remote RHs, or fan filter units. Items to consider on the air movement side include how much heat load is being generated in the system and how you're going to address this cooling need. You would address this with either solely using makeup air, which by itself is not an efficient way to deal with the sensible heat load, or by putting in sensible coils in RHs. Or in the case of FFUs, you need to determine where you put the coils. Do they go in the return chase, low or high, or on the deck? The other consideration in selecting the air delivery method is how much static pressure you will have in the system from filtration, cooling loads, and any chemical filtration needs that you might have.
Thanks. Zuri, what's important to consider with the different types of sealing grids available?
There are various types of cleanroom ceiling systems to choose from to best fit the specific space and client requirements. The main types are modular and stick-built systems. When selecting the appropriate ceiling grid for the space in question, factors such as ease of maintenance, installation flexibility, and long-term adaptability need to be considered. With a modular grid, the ceilings are pre-built and integrated with wiring, lighting, and fire protection, ready to be lifted into place. In instances where retrofitting is needed, a stick-built solution can provide more flexibility and adaptability to existing spaces. All stick-built solutions are not the same and depend on installation requirements and the support structure required for hanging. For example, less hangers mean a quicker, less labor-intensive installation.
Thanks, Ari. So there's a trend with construction workforce availability being very challenging right now. With cleanroom ceiling design, off-site manufacturing or on-site assembly needs to be considered. The chart on this slide compares some of those important aspects with modular and stick-built ceiling grids. Depending on whether the cleanroom is a new space or being retrofitted into an existing space, and what other construction is taking place at the same time, there may not be space or time for on-site assembly. A suitable partner for ceiling systems will have flexibility for that installation. A partner with a hybrid construction model should be able to deliver the ceiling grid completely built, semi-built, or ready to be built completely on-site. Zari, can you walk us through the primary structural considerations for a ceiling grid?
Yes, Bo. There are a few primary structural components to consider for the ceiling grid. First, we need to determine what loads are on top of the ceiling. This includes the weight of the ceiling itself and components on the ceiling, the air movement system, if it is attached to the ceiling, and any utility loads like fire protection, electrical, and plumbing. Secondly, are there service access requirements to the interstitial above the ceiling that require to be walkable for installation and service? This drives the ceiling and components that go on the ceiling, as well as access and safety requirements around the perimeter of the system. And thirdly, what loads will be hanging below the ceiling, if any? For semiconductor, are there multi-levels of grid, platforms, AMHS or crane systems being suspended from the ceiling? Are there any fall protection loads attached to the bottom of the ceiling? For pharma, are there any requirements for restricted access barriers or equipment to be suspended off the ceiling? These load requirements, along with suspension spans and ceiling deflection requirements, determine the type of grid to be used. And they cumulatively add up to point load requirements for the building structure. So if the building structure above cannot take these loads, then does a floor supported system need to be configured? Identifying these requirements and verifying the capability of the cleanroom partner to provide solutions will ensure that the ceiling is designed to support all essential elements.
So let's talk about cleanroom ceiling systems and often needing to accommodate lighting, sprinklers, other utilities. The design will accommodate how the ceiling system will integrate these components while maintaining the required level of cleanliness. Proper integration is essential to avoid compromising the cleanroom's functionality or contaminating the environment. The lighting industry is still making significant improvements year over year on LED efficiency and incorporating these advances into the latest fixture offerings. It's important to keep moving that needle on energy efficiency and also for regulatory demands. placement of lighting and wiring in the ceiling grid or on top of the ceiling can impact the ease of installation and the serviceability of the system also. So Zari, what other details need to be accounted for in clean room design?
Well, as you might expect, there are numerous other items to take into consideration, but we can cover a couple of them here. On the lighting side, besides the color of light in the space, depending on the process going on in the clean room, you will need to determine whether you want service of the lights from the room side or from above the ceiling. This might lead you to configure a system with flush lights or linear add-on lights below the ceiling, or maybe troffer lights above the ceiling. Generally, current LED fixture efficiency is on the order of about 130 lumens per watt. Another consideration is the distribution of circuits for lighting and air movement in terms of redundancy and emergency power. You might consider running emergency and battery backup power circuits in addition to the normal power circuits to cover power failures depending on the requirements. Another consideration on lighting is control of lights, whether you need any control at all, occupancy sensors, or dimming capabilities. On the fire protection side, a consideration is, do you use a hard pipe system where the locations of the sprinklers are fixed, or do you use a flexible hose system, which can accommodate easily moving sprinkler head locations depending on what changes below the ceiling?
Thanks, Zari. So we'll close our presentation with some comments about adapting to the future growth and the use of clean room design services. As demand for clean room production continues to increase, future expansion of an existing clean room may be required. That chosen ceiling system should be capable of adapting to these changes without requiring a lot of extensive modifications or replacements. So in instances of clean room expansion or retrofitting, a stick-built ceiling grid can integrate with the existing structure, even if the existing structure is a modular ceiling. Not all partners have the knowledge to connect the varying ceiling grid structures together. So it is important to select a partner who not only manufactures both modular and stick-built ceiling grids, but also has that expertise. With respect to design services, assisting either a greenfield or existing structure using building information modeling or BIM is common with clean room ceiling architecture. BIM is an important tool in clean room design. Architects commonly use a BIM platform called Revit. Collaboration between the clean room designer, the architect, and the mechanical and electrical disciplines all ensure that space is utilized efficiently with no clashes or access problems. And then really a clean room manufacturer who has the capability to draw the ceiling system in BIM platform will produce more refined designs that integrate into that space more seamlessly. And this can be critical in keeping projects on time and to budget also. So with that closes our presentation. Thank you for joining. Thank you, Cleanroom Technology. Thanks, Zari. And we'd be ready to take any questions.
Thanks.
Hi, I'm Mark Wheeler, the Commercial Director and part owner of the GuardTech Group, and I'm here today to discuss the fundamental principles of cleanroom design. This presentation is to support those of you that are looking to construct a new controlled environment within a new or existing facility. I'm here to share a wealth of knowledge accumulated over the past 20 years, obviously in a heavily condensed fashion, on the best way to scope out a successful cleanroom project, including key design considerations and implementing a framework that will give you the greatest chance of delivering a fully thought through project. So let's start at the very beginning, defining the reason for needing a cleanroom, which ultimately lies with your product and process, and essentially asking a series of fundamentally crucial questions to facilitate the design development. Any good project starts with an incredibly clear, well-considered and appropriately challenged brief. And one industry really leads the way as the example of best practice for this approach, the pharmaceutical industry. Pharmaceutical environments start their life as a URS, or a user requirements specification, which is a document that's been compiled and influenced by a number of key stakeholders within the business to map out an extensive set of requirements and performance criteria that must be met in order to determine project success. This document is well structured, heavily formalised, includes a sign-off and approval process, and often has been reviewed by appropriate and experienced external consultants that understand specific regulatory demands and can positively influence the content to ensure essential and important points are included. A good URS focuses on the broader performance outcomes rather than defining individual material specification, and leaves sufficient room for a range of alternative methods to be employed by the construction contractor. A common trap is compiling a URS from downloaded templates or previous projects, which can lead to demands that may be irrelevant for the current project, resulting in unnecessary build costs, whilst other highly relevant points may not be properly factored in. So the starting point to any design is assembling your ideal project team right from project inception and committing to developing your detailed brief or URS. And here are a number of questions and thoughts that you may want to consider as you begin to form and develop your cleanroom brief. Performance specification and room data sheets. Determining and recording required rooms and their associated dimensions, internal heights, classification, temperature and relative humidity levels with specified tolerances, required lux and acceptable noise levels. This part of the brief should be focused on everything that you want the environment to achieve in each of its specified zones. Process flow. Outlining clearly what happens in the space and how it happens. How do the personnel enter and leave? How do they move around the process in the most efficient manner? How do raw materials enter the space? What is the route for finished goods? How is waste collected? How are all of these things done in a manner that minimises cross-contamination opportunity? What tools can we use to minimise this risk? Transfer hatches, trolleys, HEPA-filtered good lifts, cranes. This all needs planning and documenting within process flow diagrams and schematics. And all of our decisions need to be focused on reducing movement and restricting entry to our most highly classified zones. Equipment register and general arrangements. A list of the equipment that you're using and to scale representation within your layout drawings. The dimensions and a consideration of how kit transfers into and importantly throughout the space for initial installation, considering turning circles and access points, doorway widths and heights, and potentially removable access panels. The maintenance access that's required for the kit and the clear space required around the equipment for suitable ventilation and effective operation. Utility schedule. Following on from the equipment register, defining a full utility schedule for each piece of equipment. What power is required to the kit? Does it require gas services such as nitrogen, compressed air, vacuum or extraction? And defining the associated flow rates. Is water or drainage required? What is the likely heat output so that we can factor this into the air conditioning design to compensate for the heat gains and meet the overall room condition? Personnel. The people required to run the process, determining the occupancy for each process room and outlining the likely shift pattern, thus dictating the space required for the change area to facilitate appropriate occupancy levels whilst considering switchover of operators. Product considerations. What environmental conditions does the product require whilst in production and during storage? Is it sensitive to changes in temperature, to low or high humidity conditions? Do vibration levels need to be considered? Lighting levels in terms of luminance or wavelength? Is the product vulnerable to or does it generate a static charge? These are all essential considerations that need to form definition within your requirement. Regulatory compliance. Is your product regulated by a governing body such as the MHRA, the FDA, World Health Organization or NADCAP? And if so, what guidance do you need to review, understand, consider or follow? such as EU GMP guidelines, Eudrelex Volume 4 Annex 1, and to what extent you choose to acknowledge the guidance provided by the full range of the ISO 14644 standards, and how does that govern your brief? Construction principles. How do you want your facility to be built? Would you rather the more traditional stick-built approach of on-site construction, or are you tempted to adopt a more modern approach with off-site pre-constructed pods or modules that are delivered to site in a more plug-and-play fashion? If this is the case, will those pods be installed internally within a shell, or will they be external units that need to be weather resistant? Host building. What limitations or restrictions are you presented with by the selection of your host building for the project? And are those limitations that need to be accommodated or overcome? Floor space available. An internal height of the building will determine whether it's a single or a multi-storey cleanroom, whilst considering the need for plant space above the cleanroom ceiling, usually a minimum of 800 millimetres. Is the concrete floor slab fully cured, or does it need a DPM to seal from moisture leaching? Will the building structure form part of the support strategy for the cleanroom and its infrastructure, or does it need to be a freestanding environment with independent steel portal frame to suspend from, or indeed a mezzanine serving the same purpose, whilst providing additional space for potential utilisation above? Does the building have sufficient electrical capacity to support all the process equipment and the cleanroom plant that you plan to impose? Has an electrical register been composed to determine the full load? Does an upgrade need to be factored in, as this will likely add up to 20 weeks to the delivery schedule? Is there appropriate access routes to get all components into the building and delivered to the specified space? Is there facilities on site for contractor welfare, or will this need to be included within any project costs? Is there sufficient water and drainage, and can these be incorporated without running water services over the controlled environment? Health and safety. Offset against the functionality of the process is the legislative and ethical demands of the facility, and ensuring that your environment is compliant with building regulations and safe for operation. Developing a fire strategy and planning appropriate escape routes, determining the fire rating of the structure, deciding on the fire suppression strategy, such as sprinklers or other aspiration systems, smoke detection, and whether this is also required within void spaces. Access control and door interlocks, and the appropriate override systems in the event of an emergency. Considering power outages and ensuring your escape strategy factors this in. Electronically powered rapid rise doors need particular attention here. Tying into your HVAC and filtration systems to the fire alarm to shut down critical systems in the event of a fire, and accommodating false alarms within a double knock system. Considering lone working and utilising CCTV or appropriately placed vision panels, whilst also considering privacy for changing facilities. Accommodating intercoms or other communication methods. Redundancy and future-proofing. Has the design fully considered the potential future expansion plans of the business? And does it facilitate possible extension or even upgrade, such as potentially moving up classification to accommodate new, more tightly controlled products? Is relocation a prospect? If so, this should be considered with the material selection process, with a focus on ensuring that as much of the installation materials can be retained and relocated. Has appropriate consideration been given to redundancy within the mechanical and electrical plant? Could the business afford for an air handling unit to go down, or does an N+1 strategy need adopting to ensure continuous operation? Is a UPS required or a generator to offset the risk of potential power cuts or outages? Energy management and environmental impact. Outlining the corporate objectives early on for carbon reduction and environmental impact is essential, as it will lead to only restricted materials being considered. This is especially prevalent in materials such as refrigerants, gases, and insulation types. This focus may very well also impact the strategy adopted for air handling and management. A forward forecast and review of the potential ongoing energy costs may also lead to decisions on more efficient and likely more expensive air handling equipment being selected, as a relatively quick return on investment may justify the upfront capital costs. Setback modes during periods out of operation and intelligent control systems that adjust demand based on set parameters such as particle counts can also be accommodated within this assessment. Cleanability. Reducing ledges and corners wherever possible to reduce particulate settlement. Introducing materials such as coving to make surfaces continuous. Ensuring that all materials selected are cleanable and also are compatible with the cleaning regime and materials selected for facility decontamination. And incorporating specific plants such as centralised vacuum systems to move exhaust air from clean spaces to unclassified plant areas. And lastly, project prioritisation. We refer to this as the golden triangle. Timeline, budget, quality. It's essential for project success that you determine the priority of these three outputs and how they are balanced to deliver the design required for your specific construction project. You can never achieve the highest quality environment for the lowest price delivered in the quickest time. So deciding exactly where the project sits within the triangle will help determine the design options that are selected. So as you can see, there are a wealth of questions that need tackling when pulling a complete and well-considered design together. And the answers lie with those that are closest to the process and the objectives of the business. As always, the devil is in the detail, and a design that delves as deeply as this will result in a construction project that's well informed and a controlled environment that is truly suitable for its process. I hope that this has been useful to you, and I wish you the very best of luck in designing and constructing your future cleanroom. Perhaps our paths will cross in the future. Thanks very much for listening, and keep it clean.
Everyone, and welcome to the Q&A section of today's webinar. Mark, Bo, and Zuri, thank you very much for your fantastic and very informative presentations. And we've had a lot of great questions that have come in from the audience while you guys have been doing your presentations. So let's get straight to those with a question for Bo. So, Bo, when and why to use this technology?
Sure. Thank you for the question. The right choice between ceiling grid options, it should be driven by what's most important, what criteria is most important for all stakeholders. And those needs, they will vary between the end user, building owner, the architect, the contractor, and who's partnering for the installation. The individual clean room application and the classification that's required for it generally starts that process. As talked about in our presentation, you look at whatever ISO class level, GMP or Annex 1 is required. This in turn drives the required particulate filtration levels and leads to required filtration coverage, air changes in the clean space being designed. Delivery method of makeup and recirculated air through the chosen filtration brings other options. They're guided by what's best from drivers such as serviceability, required and even desired utilities, controls and monitoring, installation, and other factors such as the space being a retrofit, or is it expansion? Is it a greenfield? Building structural capacity, schedule and availability of site labor. All of that also impacts what ceiling grid design is best suited to address those types of drivers.
All right, that's fantastic. Thank you very much, Bo. And then moving on to a question for Mark. Could you explain what is the difference between modular on-site construction and modular off-site construction?
Sure. Yeah, thanks, Brian. So essentially, we're looking at moving responsibility really from one site to another. So
Offsite construction really relates to more of a plug and play model, where we're looking at most of the construction of a pod or a module being done at the manufacturing facility of the supplier. So number of components kind of being assembled, but all of the mechanical, electrical, and structural work being done, so that it brings you to a point that when you arrive at the installation site, those things can just slot together very, very easily and form a finished unit, so that the installation time on site is significantly reduced. So from a benefits kind of perspective there, you've got obviously a much reduced time on site, which means that your health and safety risk assessments are all much easier because the time on site is much lower. You've also got a partial qualification that can be done off-site. So rather than waiting for someone to finish doing a traditional stick build, you're able to benefit from earlier qualification, and qualification that can be done without kind of risk. So it can be done with sending a team off-site to go and really focus on that rather than being pulled onto other exercises whilst they're on site. Modular on-site construction really is much more in reference to kind of modular components that can be put together, but the build itself is certainly not a plug and play kind of construction. You're looking at taking lots of individual modular components, putting them together, working your way through kind of structural, mechanical, electrical elements, and then sequencing them so that you've got a program of works that typically is significantly longer on site, and obviously carries more kind of risk of decontamination. There's flexibility that comes from that. Obviously, when you're looking at modules, there are kind of restrictions on that, but there is also with offsite construction quite a lot more cost assurity, because you're almost buying a piece of equipment that's being installed within a room rather than dealing with a host building and trying to accommodate and flex all of the challenges that building kind of presents.
All right, yep, that makes sense. Thank you very much, Mark. Then on to a question for Zuri. So how is energy efficiency being considered in new build clean rooms?
Thanks, Brian. On the airflow front, for the US specifically, there are DOE guidelines coming into play via several codes. In California, it's the CEC Title 20 and other equivalent regulations. And so these deal with selecting fans for close to peak efficiency of operation via, for example, the fan energy index metric. This FEI is determined from manufacturers per some standards like AMCA 214, amongst others. So what this is trying to do is to make sure that engineers and manufacturers are selecting equipment to run with a reasonable band of energy efficiency, or run within a reasonable band of efficiency, and that they're not too far off from peak efficiency. And then more generally on the design side, for clean rooms that can afford to reduce airflow during non-critical periods, it's important to take advantage of turn down while not letting the particle counts have too much excursion, so that you have a reasonable recovery time. And of course, this would not apply for production type facilities where you cannot have these deviations from the baseline performance that you set. So that's important to know that. Similarly, on the lighting side, you can build in dimming and occupancy sensors into the system, in addition to accurately modeling light levels up front. Yeah.
All right, great, thank you. So I'm going to continue to alternate the questions now between Mark and Zuri. So back over to Mark. Has Annex 1 altered your approach in designing clean rooms? And if yes, how so?
Yeah, so I think the fact that there's the release of, or the re-release of any standard kind of brings a renewed focus. And I think what that does is it means that a lot of clients have actually started to just get to grips once again with Annex 1. So although obviously the pharmaceutical industry, it's kind of, a document that they keep very close to their heart, I think sometimes it's easy to feel that you kind of know it inside out. So I don't think it's necessarily even just the changes to Annex 1. It's also just actually the fact that people are acquainting themselves with Annex 1 and some of the demands that are in there. And that's certainly influencing some of the approach to design. So I think the contamination control strategy is probably one of the biggest areas that we've seen quite a renewed focus on people and the way that they look at their URS. So we're getting much more detailed URSs now. I think there was a history really of a lot of template URS creation where people would take project information from another project and kind of cut and paste and take things that they found off the net. And we were seeing a lot of URSs that had a quite a generic kind of feel to them. There's a lot more specifics that are coming into the URSs that we're seeing at the moment, where people are really considering their facilities. There is also quite often looking at the new guidance and looking at their existing facilities and altering their kind of site-wide approach. So from some of the kind of the blue chips, from some of the larger players, where before they've kind of adopted a site-wide approach that is based on some of their other facilities. Now there's more of a kind of modernization of that approach and really questioning their URSs and moving away from the the more template approach. And certainly things like we've certainly seen a lot more requests for CCTV, for example, where people are trying to get much more tight process control, trying to monitor their process further. So we're seeing Windows and CCTV has taken a lot more prevalence in URSs than it previously did. Design qualifications as well. I think that's something that we're really seeing people want a very well evidenced call and response in their URS. And design qualification, and seeing a very tight correlation between the two. So making sure that we're not just saying that there's compliance with a point, actually putting some evidence in to explain how that point has been met within the design qualification. And I think the last thing for us has really been a focus on the layout. We're certainly seeing a lot more space given over to change zones and more airlocks being implemented as people are kind of interpreting the in-out and the separation of materials and personnel. They're taking that a lot more literally than maybe they did before. I think before there was kind of more of an approach of it being open to interpretation. I think now maybe that's not so much the case. Mm-hmm. And then what that is doing to the pressure cascades, because we're implementing more airlocks, the cascade between rooms, we're having to really take closer to the knuckle and look at a 10 Pascal pressure cascade rather than a 15, because otherwise we're ending up at too high of an absolute pressure as we work our way through the facility. So I think they're probably the biggest changes that we've seen.
All right, that's interesting. Thank you very much, Mark. Back over to Zuri. What are some of the largest obstacles in maintaining a clean room?
From a product supply standpoint, we strive to provide the most reliable equipment possible within the project budget. But the importance of designing for serviceability cannot be overstated. So this would come from the serviceability of components or built-in redundancy of components to minimize excursions in the event that something ever goes down. Mm-hmm. For example, if there are a lot of tools and equipment in the clean room that make access to the ceiling difficult, it's critical to have good interstitial access to service components. And if that's not accounted for up front, that can make it difficult for the sustaining folks to deal with issues in a timely manner. So.
All right, that's great. Thank you very much. Mark, what aspects are commonly missed when architects design clean rooms?
So certainly not to throw any architects under the bus, because we work with lots of architects, and there are some excellent agencies out there. I think the one thing that we see a lot of as being, I suppose, a benefit to our service is a very coherent approach to design. So rather than a multidisciplinary team that aren't necessarily clean room focused, architects quite often will sub out to individual specialists and work kind of in a project management way where they're pulling that design together. And there's certainly some benefits to that, but I think there's also some negatives, because you end up with independent designers with a very singular brief that aren't necessarily considering the whole picture. I think the biggest things that we see as a result of that, future proofing is one of the areas where I don't think there's necessarily enough consideration. There's a lot of consideration on the needs of the business today and how the facility will meet the process demands of what the client is doing, today and maybe for the next 12, 18 months. But what we try to do when we're looking at design is really map out how do we sweat the asset as hard as we can. So looking at that space and optimizing it in a way that we can either allow for future expansion or look at what we've got today and accommodating enough services that you could include more equipment. So that could be things like, electrical sockets, not putting enough electrical sockets in. Therefore, kind of the way that works its way back down the design is that people haven't considered, has the building got enough electrical capacity to serve the future kind of needs of the business? One of the things that I think we like to, when we look at, especially with things like, warehouse builds, using every inch of that space, there's kind of a propensity to look at floor space and use that as your kind of determining factor, and then kind of avoid the fact that you've got maybe an 8-meter high warehouse that you could be making the best use of. With a lot of clean rooms, the suspension is coming usually from maybe a steel portal frame or from a mezzanine structure, or something that we can put over the top of our ceilings, and take suspension from. If we do that in a certain way, we can allow that space above to be built on in the future and start to see kind of double stack, maybe triple stack clean rooms, office space, lab space, whatever it might be. If it's built in another way, which might be more cost effective today, what you end up with is a poor design for the future. So someone comes in and says, well, actually, we can't build on top of this because there's too many clashes. We'd have to take the clean room down for 6 weeks in order to retrofit the frame XYZ. So we try as much as possible to look at that upward trajectory as well. Can we build a multi-level facility rather than spreading that entire facility out? Can we either go upwards and build a 2-story, 3-story clean room and look at the materials transfer process between clean room lifts, all those kind of things that we've built bespoke in the past? Or can we at least accommodate for it? So can we take the full footprint of the the ground floor and then look at making sure that the infrastructure above can sustain an upgrade in the future, another clean room up there, a lab, something more. So I think there's some of the key things. And again, I think redundancy maybe doesn't get the level of concern that it should do. Looking at the process and understanding how important that is, and what would it look like if, let's say, the air handling unit was down for 3 days for a repair. What does that look like in terms of cost of loss of production? And using that as a metric for return on investment for looking at N+1 redundancy, putting in another air handler and a switchover valve that gives you the capacity to ensure that even if it's maintenance, you can just switch over your airstream to another air handler and keep the facility running. So I think there's some of the key points of when you've designed. I've been in the game a long time, and we've been doing this for over 25 years. We've seen a lot of mistakes, and that catalogue of mistakes is very, very useful because everybody benefits in the future from what you've seen in the past. And I think sometimes architects don't necessarily have that specific book of mistakes. They've got more generic.
Yeah, no, that makes perfect sense. And that actually, thank you very much for that, Mark. And that leads quite nicely into the next question that I've got for you, Zuri, which is, what do you see as the most prominent misstep that clean rooms take during the design process?
A lot of what Mark mentioned, really building in redundancy is one of the key things in general clean room design. But on the structural side, it's making sure that all loads, all the required loads are defined up front as much as possible. In existing buildings, the capacity of the structure is set, which might drive you to a floor supported system, if the ceiling cannot take it. So that decision is somewhat binary. But on greenfield sites, however, this could be an iterative process to optimize the capacity of the structure. And so just working through that is really important.
Yeah. Okay, thank you very much. Mark, how is energy efficiency being considered in new build clean rooms?
So I think energy efficiency kind of probably is probably wider than that, Brian. So I think it's not just energy efficiency, it's also kind of environmental impact and carbon reduction. With the term carbon reduction is something that's really crept into the lexicon of briefs over the last couple of years, and it certainly will just continue to go that way. We're seeing that a lot in things like material selection. So, for example, when it comes to air handling, looking at not only the performance of the air handler, but things like the refrigerant, the types of refrigerant that clients are prepared to accept versus the types that they're not prepared to accept. And that can bring its own challenges, because for kind of quite large scale projects and large scale equipment, quite often there's enough money in it that the manufacturers have kind of spent some time, invested some time on, making those as energy efficient as possible. And when you're working with, large clients that are used to working with big air handlers, they're kind of expecting to see those same principles applied. If they're then doing a small project where they're only working with small pieces of kit, you don't always see the same kind of investment from the manufacturers in those small pieces of equipment, because they're just not as valuable to them. And it will come, but it isn't quite there yet. So sometimes those expectations from the client of like the carbon reduction that they've seen in the big pieces of equipment don't always transpire to the smaller jobs. So it's then challenging what the client is asking for, and saying, look, this is what the market has available, and there's always more than one ways to skin a cat. And whether we look at moving them across to a chilled water system rather than a DX air handler, but it's trying to sometimes shift the mindset that just because you're using large air handlers elsewhere, and you've managed to, with those manufacturers, make those efficiencies, we can't always apply the same kind of principles. So I think that's from a carbon reduction point of view, kind of what we're seeing. In terms of running, really, it's about intelligent controls, and certainly the old approach was always kind of setback modes and looking at your shift pattern and saying, okay, we're going to run with the air handler, depending on whether there's product left in the room overnight or not. And there's a number of influential factors, but the broad kind of approach was that we're going to approach this with some kind of a setback mode in the evening while we're not in there, which means that we can maybe widen our temperature bands, widen our humidity bands, and allow that room to run with less energy behind it. What we're seeing now, I think, is more of because particle counts are becoming, they're just obviously the driving factor, certainly in the pharmaceutical industry. And, I need to add that this does vary across industries. We work across, the whole kind of STEM range. So aerospace haven't got the same kind of consideration as pharmaceutical do, for example, or automotive. But this drive towards making sure that the particle count, on one hand, there's the risk management of making sure that room stays functional and within classification, and the other driver that's coming maybe from elsewhere in the site, you've got quality pulling one way and you've got facilities pulling another, because worldwide headquarters are saying we need to achieve both briefs. So I think intelligent kind of particle counting and using particle counters to drive your air handlers, we're seeing a lot more of that controls philosophy, clients being very open to that. So even though there's quite a cost associated with that, it manages to achieve both of those aims. And again, there's some return on investment. We're having to do quite a lot of energy assessment costs now, where we're looking at what would be the cost of X unit versus Y unit, and what would be the payback time on that. So we're kind of having to work with the clients to do a lot of those calculations to help them say, well, actually, you're looking at an 18-month return on investment. This probably makes sense. The other thing I think is with the change in or certainly with Part 16 in ISO 14644 and with the updates to Part 4, there's now more challenge on air change rates, and there's certainly more appetite to consider source strengths. But we're still kind of at a juncture where we haven't seen equipment manufacturers really be able to provide any valuable data on particle source strength. So we're still very much working to an air change rate model, but certainly there is more acceptance of a lower air change rate than there was before. Whereas before the client would look at the standard and look at the recommendation, which has got in my opinion, vastly higher than necessary air change rates. And they would use that to form part of their URS or their brief. Now they're much more open to an approach of, energy efficiency and saying, okay, well, we're prepared to listen to your experience and what you've done with previous environments. Sorry, a bit of a long-winded answer there.
Yeah, well, it's a very big topic, isn't it? There's lots to discuss in the area of energy efficiency and carbon reduction and all the stuff you spoke about. So I'm sure the detail will be appreciated, so don't worry about that. Just a couple more questions for you, Zuri. You mentioned in your presentation fan efficiency guidelines. So how do you address those with your products?
So the FEI, specifically for the US, it addresses wire to air performance, so fans drawing above about a 1 horsepower. So this is combining fan motor and drive input watts for a given airflow and static pressure performance point, and comparing that to a reference standard. So we address that with fan wall technology and handlers, where we dial in fan selections to specific operating points, and we vary wheel widths and things like that to give you an optimized performance efficiency point. At the same time, we provide built-in redundancy on the fan level without necessarily having to do redundancy on the unit level. Sometimes you do have to do it on the unit level too. Then we also offer IE5 efficiency motors, or IE5 plus even, getting closer to IE6 maybe, which utilize variations of permanent magnet and synchronous reluctant technologies, motor technologies and drive technologies, in lieu of standard NEMA premium motors for the US at least. So this further boosts efficiency, especially on turn down conditions. Yeah.
Yeah.
So those are some of the ways we address that. Yeah.
Yeah. Okay, great. And then finally, Zuri, what are some regulatory considerations?
Besides what Marcus talked about on GMP Annex 1 and ISO 14644, there are some product considerations too, and specifically on the products that a manufacturer supply. There's the standard structural and seismic codes, at least for the US, like the IBC, and then it's important to consider that there's some local codes that can govern also or have effect for the local building regulations. On the lighting front, there's UL on the US side again, UL 1598, and on the LEDs, UL 8750. Those are some standards. And LEDs are very changing. The LED lighting and the chips are changing very rapidly. So it's almost like you have to keep up with that every year as a product supplier. And sometimes it's for semiconductor manufacturing, lithography areas, it can be challenging to meet California Title 24 and other energy codes that are being adopted around with amber lighting requirements. There's ways to deal with that. And air movement devices like air handlers need to meet UL 60335, which is a new standard just coming into effect right now. And FFU side is UL 507, but the former 60335 is rolling out this year. So those are some things to consider.
Yeah, absolutely. Thank you so much, guys, for all your answers, but that is all that we've got time for now. There have been a lot of other questions that have come in from the audience, not only during the registration process, but also while you guys have been doing your presentations, but we simply don't have time to get through them all. But the questions will be supplied to you guys, so that then you are able to follow up with all the people that have tuned in so that they're not left hanging. So big thanks to everyone that's tuned in, and a big thanks to Bo, Zuri, and Mark for their fantastic presentations and taking the time out of their day to talk on the Q&A as well. And a big thanks to everybody in the On24 team, because without them, we wouldn't be able to put on these webinars. They make it all work from a technical point of view. So thank you very much. And for everyone that's tuned in, but would like to revisit any of the content or look at any of the presentations again or revisit parts of the Q&A, this will remain available on demand. So please do feel free to come back and revisit it. And the third installment in the Cleanroom Technology webinar series is coming up soon. So stay tuned for announcements on that. But that is all for today. And we look forward to seeing you next time. Thank you very much.